Hello students, welcome to Saurabh's classes. Today we will be solving the Isi M.Stat question paper of year 2017. Previously, we have solved question number 1 to 11. Today, we will be solving question number 12 and question number 13 from the same paper. So let's begin with question number 12. A function f which goes from r to r such that f of x is equal to f of minus x for all x and has left hand derivative 5 at x equal to 0. Then the right hand derivative of f at x equal to 0, we have to check these four equal options, whether it exists and is equal to minus 5, whether it may or may not exist, whether it does not exist, or whether it exists and equals 5. So let's begin. Now we have been given that f of x is equal to f of minus x. This is an even function. The function f is an even function. So let's begin. Now the right hand derivative at x equal to 0 is given by limit h tends to 0 plus f of h minus f of 0 by h, and this is equal to limit h tends to 0 plus f of h. We can write f of h as f of minus h minus f of 0 by h, and this is equal to limit. Now if we take h as minus, we substitute h by minus h, then h is tending to 0 positive and minus h will tend to 0 negative, and that comes down to negative of minus h plus f of 0 by minus h. Let's use the space below. Now if we take a value k which is equal to minus h, then right hand derivative at x equal to 0 will come down to limit k tends to 0 minus f of 0 minus f of k by k, and that is equal to the left hand derivative, and that is equal to 5. Therefore the left hand derivative is equal to right hand derivative, and both of them are equal to 5 at x equal to 0. Therefore it exists. That we are basically concerned with RSD, so basically we can say that right hand derivative exists at x equal to 0. So the option D is correct. So now let's move on to the next question. Now let us solve question number 13. In question number 13, it has been said that let f be a function which goes from r to r and is defined by f of x is equal to summation of 1 by 2 to the power k, where k goes from 0 to greatest integer of mod of x. Now it has been said that greatest integer y, the symbol used here is this. This is not the typical greatest integer function symbol, not the typical greatest integer function symbol. The typical greatest integer function symbol is given by this. So here this symbol denotes the greatest integer less than or equal to y. So then we have to find whether f is a left continuous function which is not right continuous, or whether f is a continuous function, whether f is neither left continuous nor right continuous, or whether f is a right continuous function which is not left continuous. So we have to check these four options. So for solving this, we'll assume some value x equal to x naught, which will once be fractional and when it will be equal to some integer. So these are the two cases that we have to check. So let's start with the fractional case. Let me use the space below to make you understand more properly. Okay, it's better that I use a new page to solve this problem. So case 1. I'll show it graphically so that it's easy for you to understand. Here we have taken that x is equal to x naught and it is fractional and lies between two adjacent integers. Now it has been said that here they have said that we have to find out the greatest integer of mod of x. Greatest integer of mod of x. Now if we take x equal to x naught, then now x naught can be a negative number and it can also be a positive number. In case x naught is a negative number, then a mod of x naught will lead to a positive number, and that positive number we'll take it lies between two numbers n and n plus 1. Here n and n plus 1 are two integers. n plus 1 belong to integer set z. So and x naught is somewhere in between, or basically x naught mod. We can take x naught mod. In that case, the left hand limit is given by limit x tends to x naught minus f of x, and that is equal to limit x tends to x naught minus f of x is given by summation 1 by 2 to the power k, where k goes from 0 to greatest integer of mod of x. I'm using a different symbol over here, but the meaning is the same. So it will come down to, so now basically if we go to the refer back to the graph below, we'll find out, let me use a different thing for this purpose. We'll find out that as x tends to x naught minus, we are basically in this vicinity. So basically we can find out that as x naught tends to x naught minus, then we are in this vicinity. In this vicinity, the value of the greatest integer value of x naught is equal to n. So basically we can write that this value is it comes down to limit x tends to x naught minus summation of 1 by 2 to the power k, where k goes from 0 to n. This is the left hand limit. Now let us find out the right hand limit. Right hand limit is given by limit x tends to x naught plus f of x is given by summation 1 by 2 to the power k, where k goes from 0 to greatest integer mod of x naught. Now x tends to x naught plus, so we are basically referring to this vicinity. In this vicinity also we can find out that the greatest integer of mod of x naught will ultimately tend to n, since it is less than n plus 1. So this comes down to limit x tends to x naught plus summation 1 by 2 to the power k, where k goes from 0 to n. So here the left hand limit is equal to the right hand limit. So for case 1, Let me use the space below. So if x naught is a fractional value between two adjacent integers, then LHL is equal to RHL, or we can say that the limit that f is continuous at x naught. Now we'll move forward to the next case. So I'll insert one more page here. Case 2. X naught is equal to some integral value. Let x naught is equal to n. We'll use the same example as below. So basically, if it is n, then n is equal to x naught. So now let us find out the left hand limit at this point. At the left hand limit at this point, it is given by limit x tends to x naught plus, sorry, I have done a mistake. I have committed, it will be x naught minus, let me rub it off, x naught minus f of x, and this is equal to limit x tends to x naught minus summation of 1 by 2 to the power k, where k goes from 0 to greatest integer of mod of x. So here, as x tends to x naught minus, so this is the portion that is indicated. In this case, the value of greatest integer of mod of x naught will not be n, it will be equal to n minus 1, the intermediate integer here. So this will come down to limit x tends to x naught minus summation k goes from 0 to n minus 1 by 2 to the power k. Similarly, if we find out the right hand limit, we'll come down to limit x tends to x naught plus f of x, which is equal to limit x tends to x naught plus summation of 1 by 2 to the power k, where k goes from 0 to greatest integer of x naught. In that case, when we go from x tends to x naught plus, this is the portion that we are referring, but x naught plus will be some very much less than the adjacent integer n plus 1. So in this case, the value of greatest integer of mod of x naught will be equal to n in this case. So the right hand limit will be equal to limit x tends to x naught plus summation of 1 by 2 to the power k, where k goes from 0 to n. Let me use some more space below. So here, if x naught is equal to n, where n is an integral value, then LHL is not equal to RHL or is not continuous. So basically we can say that for any value, for any x naught, the function will be continuous here for some n, but here there will be some discontinuity. So it is right, therefore f is right continuous but not left continuous. So the option D is the correct option. So today we have solved question number 12 and 13 from the ISI M.Stat question paper of 2017. We will be solving the next questions in the upcoming videos. Thank you for watching Saurabh's classes and Saurabh's videos, and all the best for the upcoming exams. Thank you very much.